Standard 8113, determine rational approximations for solutions to problems involving real numbers. We will probably be dealing with some Pythagorean theorem here. Remember, Pythagorean theorem is a squared plus b squared equals c squared. You find that right angle. Once you find that right angle, opposite of the right angle is side C. Side C known as your hypotenuse. It is always the longest side of the triangle. Part A says a rectangle measures 7 centimeters by 11 centimeters. Part A says what is the length of each diagonal expressed as a radical. A radical, all a radical is a square root. So we need to express our answer as a radical. Part A, down here, the first thing I would do is go ahead and construct that rectangle. We know it is 7 centimeters by 11 centimeters. We need to find the diagonal going through that. So basically, if you think about it, the diagonal is broke down into a triangle then. So then opposite of that right angle there is x, or side C, known as the hypotenuse. So now you're going to use your equation a squared plus b squared equals c squared. Plug in 7 and 11, those are both legs, and you're solving for x. Do your squares, 7 squared is 49, 11 squared is 121. Add them together, we get 170. X is still not alone, x is being squared. To get rid of a square, we do the square root. And remember, our answer is going to be expressed as a radical in part A. So our answer in part A is the square root of 170 centimeters. Part B says what is the length of each diagonal to the nearest tenth. So we need to round to 1 decimal point. Find the square root of 170 in our calculator, round to a tenth, and we get 13.0 kilometers. When we round it, we have to leave that point 0. If we got 13 exactly, we could put 13 down. We didn't. We got it by rounding, so I need to put that 0 in to hold place value. Which is the best estimate of the length of each side of a square? What do we know about a squared? Well, we know the side times side. Well, the sides are the same length. So the area of a square equals side squared. When we do this, we get plug in our value that we know. 76 is our area, equals s squared. Now we need to get s alone, so I'd find the square root of both sides. When I find the square root of both sides, I find that s equals about 8.7 centimeters rounded. So the closest answer here would be A, for example 2. An 18-foot ladder is leaning against the house. Here's that 18-foot ladder leaning against the house right here. If the base of the ladder is 6 feet away, here's the base of the ladder, is 6 feet away from the house, about how far up is the house? Up the house is the ladder. So here's the house where that ladder goes up. Well, here's my right angle. Opposite is side C. So we know side C. So start out with your a squared plus b squared equals c squared. We know that C is 18, so we're going to put 18 in there, square it. 6 can go in for A or B. So next part, you go ahead and drop down a squared plus 6 squared is 36 equals 18 squared. 18 squared is 324. Need to get A alone. Subtract by 36 on both sides. We have a squared equals 324, take away 36 is 288. And the last thing to do to get A alone, well, do the square root. So I square root both sides. We find A is approximately 16.97 feet. So I look at my examples here, and 16.97 would be pretty darn close to 17. So that's our answer there for example 3. This concludes 8113.